Hey, what's up guys, my name is Cherno and welcome to episode 6 of Sparky Engine series where we're going to create an engine from scratch in C++. So last time we implemented some mat4s, right? Some 4x4 matrices and they were all nice. Now one thing I do want to point out is I saw a comment and of course I need to fix this. In my perspective matrix I was returning C. So let's not return C, which is a float. Let's return result. So let's quickly go into that. So this is under perspective, and let's return result. Okay, again, we would have caught this straight away if we actually had shaders and whatnot, but I don't think I made any other silly errors like that. Cool. Anyway, back to business. Let's go ahead and talk about shaders. Okay, so shaders are essentially ways to program our graphics cards. When we send any kind of data to the graphics card, so we're like, here's an array full of vertices and indices and texture coordinates and textures and everything. The graphics card has no idea what to do with this information. So we need to tell it, catch all of the stuff I'm giving you and do something with it. Okay, preferably draw it to the screen in certain ways as well. So what we need to do is set up a system so that we can write our own shaders. Okay, because they're going to be very, very important for games, okay, and graphics. So to do that, we need to do a few things. So firstly, shaders are usually written as separate files. You don't have to write them as separate files. You can just write them as strings, but usually you would write them as separate files. So we currently have no capability in our game engine to actually read files, and we need that. So the first thing we're going to do is write a file reading class. So under source, I'm going to make a new folder called utils, which is going to stand for utilities, and then underneath that I'm going to make a header file called fileutils.h. okay, and I'm going to pragma once that. The stuff we'll need probably will be, let's see, so I guess we'll just import stuff as we need them. Yeah, so we'll start off with this, but it'll be in namespace Sparky, and then I guess I'll probably just leave it like that. I don't think I'll put it into another namespace like utils or whatever. We'll leave it here. So so to read a file, I'm going to return a string, a standard string. Okay, we will, let's see, so we'll call it read file. I'm going to call it lowercase. So okay, not log. Okay, so let me quickly mention this. Anything that is a function, anything that is not part of a class, anything that is not a method, I'm going to write using this naming convention, okay? Where instead of having camel case like this, we just have underscores in between words, and everything is lowercase, okay? We used this same thing in Window when we made our functions, like all these callbacks. You can see that they're not part of the class. They are actually part of the class, they're friends, but they're treated the same way as if they were simple functions, okay? Because that's actually what we had them as before, okay? So all these callbacks are simply functions, okay? Essentially, right? Because they're not actually part of the class. So, that being said, let's go ahead and write this method, or write this function. So, it's going to take in a file path. So, that's the file that we'll be reading. One thing we will need to include is string, of course, if we want strings. And we'll also have to use it because we'll be using a few different things. But let's go ahead and create this. So how are we going to read files? Well, you can do file reading a number of different ways. We're going to do it using just the standard C like way of reading files, using a file. The reason is this is much faster than ifstream, and I might actually do a video comparing the two because it might be an interesting thing to do. I don't know if I have time, but this is much faster than actually using ifstream. So yeah, so you can, there is I guess the main C++ way of doing things would be by including fstream and then using ifstream file or whatever, and then you can take in your file path and whatnot, but this is much faster. So let's set that equal to fopen, which will open our file. So we're going to go ahead and, so file path is obviously the file path, and then mode. So mode is essentially certain flags we can set to how we want to open this file. So we want to open it for reading only, which is why we're going to specify R. And we want it to be a text file. We want to tell it that this is not a binary file or anything. This is a text file, okay? Now, if we do it as if we read it in as a text file, the difference really is the fact that it'll use proper line endings and it'll recognize proper line endings. Binary files, of course, don't really have line endings, right? They're just a bunch of bytes. But text files do. Okay, so when we read our shaders, it's really important that we actually have line endings, because if you look at if I were to write a simple shader over here, for example, the first thing usually in a shader is version, right? So if you have something like version 330 core, right, and then of course you have your main for your shader, right? Then if there are no proper line endings, this will be on one line and suddenly it'll be part of the hash, and you'll just get invalid stuff. So you need to make sure that your line endings are pristine. So to ensure that, we're going to make sure that we read it in as a text file. Okay, next up. We actually need to see how large the file is, right? We want to see how long it is. So in order to do that, we actually have to navigate to the end of the file using fseek. So the file that we'll be navigating to the end of is file. Again, this isn't written as a object-oriented file thing, right? So in C++, then, if this was an object-oriented file, like class, we could do something like file.seek or something like that, but because it's a C library, we can't actually do that. We have to use the old procedural way. So if you guys are confused as to why this is looking weird or whatever, and you've come from Java, this is why, okay? Because this isn't like a C++ thing with objects. It's just a C. It's just a C library. That's all. That's all it is. So we want to go to the very end of the file. So we pass in seek end, and then once we've done that, we can actually retrieve the length, okay, which is typically an unsigned long. So to retrieve the length, we can just use ftell and then the file, all right, and that'll give us the number of bytes, or the number of bytes that it's read, essentially. Okay, cool. So now that's done. In fact, ftell might actually give us the number of characters it's read, because this isn't a binary file. Let's find out. Yes. So if it so for binary streams, it is the number of bytes, but not for text streams. So yeah, keep that in mind. Cool. Anyway, next up. So now that we've got the length, and the reason we figured out the length, by the way, is that, okay, so a few things. It is actually the number of bytes, okay? And the reason this is important is because we can now make a character array that we'll use to read into this. So if I make a character array, and I'll call this data because this is the wrong data, I'm going to pass in length, which will be, remember, one character is 1 byte, so length, and then the +1 is here because I want a termination character at the end of it to tell it that this string is terminated, okay, which is important when we want to use it as a normal string. So you'll see. Okay, cool. So now what we have to do is use memset to actually set all of this to 0. Okay, because ftell is a touch broken and it'll give us some extra bytes essentially, so there'll be a problem. Okay. Yes, so let's see. What am I doing again? Okay, and then this will be length +1. Okay, so we've set everything to 0. And now we can go ahead and seek. Okay, so now we want to reset the seek position so that we're back to the beginning, because we went to the end so that we could see the file length. But now we go back to the beginning, and we want to read into data. Let's see, element size 1, the size or the count will be our length, and then the file that we're reading, of course, will be file. Again, I don't know, I feel like file should be the first parameter here, but it's not. Whatever, it's just the way it is. Once we've read all that, we can close the file. And then we can go ahead and create our string, which is going to be our result. And we'll just go ahead and pass in file like this. Oh, sorry, not file, data, like that, all right? As soon as we've copied that data across into the string, we can delete it. In fact, we need to delete it, otherwise it'll remain in memory. And then we can simply return our result, okay? Done. So there we go. That is our read file thing. It should work pretty well. If we want to test it, we can quickly go to main and go ahead and say, over here, I'll just type in, well, we'll include source, utils, file utils. We'll go ahead and string file equals, read file. This will be, we'll just read the current file, so main.cpp. And we'll output it. Okay, cool. And then we can just return so we don't do the rest of that stuff. And, or in fact, let me just grab, oh, we're not doing that anymore. Okay. I thought we were still system pausing at the end, but I guess we're not. So system pause. Alright, so if we run this, okay, so one thing you will get is, we should probably make sure that we're returning a value as well. But one thing you will get is basically a deprecation warning, where it'll be like, lol, don't use fopen, it's insecure, use fopen-s, which is the secure option, whatever. All this hatred will be projected towards us. We can fix that. If you go into, it actually tells us how to fix it as well. But you can see it says to disable deprecation, use CRT secure no warnings. Okay, so if we right click, go to properties, and then under C++ and preprocessor, under preprocessor definitions, where we define glue static, we also want to include or define secure CRT secure no warnings. Okay, there we go. And now that error will go away. So if we build it now, we shouldn't get a problem. And if we run it, you can see it should read our file in its entirety all the way over here. Now, one of the things that might pop up in questions is, why did I use the memset to set all the bytes to 0? If I get rid of that, you'll see artifacts and stuff at the end, okay? Because, yeah, just because of the way that we read files, and just because of the way that it doesn't know where the termination character is unless it's 0. So if we do this, it will ensure that it reads our file properly, okay? Or rather, creates it properly into a string. Okay, cool. So, there we go. So now we can read files. Yay. So let's talk about shaders. Shaders. So in graphics, I'm going to make a new item. Hard to believe we've only got one class in graphics, but anyway, London Dare's approaching. Shader.h. So let's go into window.h and copy our namespace stuff. Pragma once. This will be in the graphics namespace, of course. Thanks, Visual Studio. It's not like I wanted to have it on the same line or anything. Alright, so class shader. So shader classes are pretty cool. The only thing this is going to do is manage our shader for us. So it's going to load our shader in. So from a file, right? We've already got something that can load files. In fact, we should probably include that. So include utils, file utils, right? It's also going to manage sending data to the shader and enabling and disabling shaders, okay? And storing uniform locations as well, which we'll cover. So the first thing that we should have, right, is, and let's include glue as well. Sorry, GL glue, right? Is a unsigned int, okay? Which is our shader, okay? So this is our OpenGL shader ID. So once we create a shader, OpenGL gives us a number, essentially, an unsigned int, so that we can refer to that shader later, okay? If we want to do stuff. Kind of like the same thing that we did with, where are we? In file utils, right? Where we had a file, and we had to pass in that pointer every time we wanted to do something with a file. Same thing in OpenGL, right? we have to pass in this shader ID every time we want to do something that concerns the shader. So that's our ID, okay? And then what I'll do here is we'll take in a shader. So when we load in a shader, typically we want to load in usually at least a vertex and fragment shader. Of course, there are other shaders like geometry and tessellation shaders. We're not going to cover them just yet because we don't really need them for now. But we'll probably, the engine will probably support them eventually, but just not now. So we'll have two file paths. We'll have the vertex path, or the path to the vertex shader, and then the path to the fragment shader. Okay, that'll be our main constructor. We'll also have a destructor. I'm not sure if we'll use that, but we probably will. And let's see. And then I guess we'll have like enable and disable, which will just, they'll be basically just an abstraction for GLU's program, which will use this current shader. Okay, anyway, this is our basic shader class. We'll add a lot more in a minute, but let's go ahead and start implementing it. So CPP file called shader. All right, fantastic. So let's include shader. Let's include our namespace. So, let's start with the constructor. Const char vert path. Const char frag path. Okay, so we probably won't get this to actually load it. I mean, we could, but I don't think so. So I'm going to make a private method here that will just handle the loading. We'll just have a separate method for it. It'll return the ID, and we'll call it something like load. And then it'll take in the file paths. I'm actually going to keep the file paths here, and I'm going to make them up here. So we'll have vert path or m vert path and m frag path. The reason I'm keeping them up here is for debugging purposes, okay? Because when you get an error or a certain shader fails to compile, or not even that, but you're trying to set a uniform and the shader is incorrect, it can help to see which shader is throwing that error. So by having this stuff here, you will be able to recall that. Let me just make sure that that's a conversion. Okay, so that's why I'm doing that. And then we'll have load. We might disable this stuff in release builds or something. It's not really going to harm us too much if we don't, though. Why are you mad? Oh, okay. We can fix that. So, frag path is vert path is going to be set to vert path, and frag path is going to be set to frag path. All right. Yay. So let's move on. Okay. So we're going to set m shader ID or m shader equal to, I'll call it m shader ID. We'll set that equal to load. Okay, let's go back. Okay, cool. So this is where the fun begins, because we're going to actually load our stuff now. So why did I come here? To change this, of course. Loading shaders is just a ton of fun, really. Okay, I'm saying this somewhat unenthusiastically because it's actually not that fun. It's a bunch of boilerplate code. So, to load a shader, let's talk about this in rough detail. So what we're going to need first of all is to generate a program. So under GLU int, I'm going to go ahead and say, we'll call this something like result, or I think I'll just call it program though because it's a bit better. And then I'm going to call GL create program, okay? So a program is basically all of our shaders into one kind of program, right? So as I mentioned, shaders are a way to program the graphics card. They require there are many different types of shaders, such as well, you know, vertex, fragment, tessellation, geometry. All these different shaders, but they're individually they don't really do anything. You need at least a vertex and a fragment shader, okay? The vertex does stuff per vertex. The fragment does stuff per fragment, which is usually per pixel. So the idea with that is we need both of them to function, and obviously for both of them to function, we need to link both of them into a program, okay? So we want to make a program out of our shaders. And then this will generate a new program ID so that we can start creating our program out of the actual shaders that we pass in here. So that is the idea. So let's go ahead and create a vertex shader. I'll call it vertex. And then we'll pass in GL shader vertex. Or what is it? GL vertex shader. Alright, we'll do the exact same thing for the fragment shader. Alright, and then we'll go ahead and set the shader source. So we need to actually read it. So let's go ahead and read it. So std string, let's just say vert source is going to be read file. And what we're going to read is the file path, which is just mvert path. Not IBM Vertex Realist. What is it? Vert path. Oh my goodness. Oh, it's because I'm pressing the wrong thing. Okay, so we've got our vertex source. We're going to have our fragment source. Okay, and then what? Let's see. Well, what are we? Oh, ha! This is actually good. I'm really glad this happened. This is why it's important to not define pointers here, because when you do it for multiple things like this, each of these actually has to have an asterisk next to it. Okay, very important, and you can see that fixed our error. Okay, so you can either do that, or I'm just going to do it differently. I'm going to actually declare them on different lines, just because. But yeah, keep that in mind. Each thing in a row needs an asterisk next to it if it's a pointer. Okay, because otherwise it makes the other thing just one constant character, not an array of constant characters, or not a pointer to that. Okay, great. So next up, we need to actually load in our shader sources. So GL shader source. Okay, we're going to pass in. So what the first thing it wants is the shader, which is vertex. That's shader ID, right? Then it wants the count, so just one. And then what it wants is a GL char of strings, and there's 2 pointers in there. So we need to pass in the address of this vertex source, or vert source, C string. All right. Cool, we might have to just... What does that apply to again? I think that will fix it. No. We'll figure it out in a minute. Well, let's just finish this line. And then we need the... let's see, what else do we need? Oh, just null. Okay, cool. So, why are you screaming at me? Const char... Verts... I don't know. Vert... V. I'm gonna run out of names soon. There's going to be that. And I don't know why I made it a reference. Lol. And then we'll pass in that. Okay. In fact, we could probably just simplify this a lot. If we did something like this. Okay, and then we can just pass in that, okay? And then we'll do the same for this. Okay, now that these guys are in here, we can actually compile the shader by calling GL compile shader, and the shader we're compiling is vertex, okay? Assuming this works, we're all good. But unfortunately, if we have any errors in our shader, such as like syntax errors, for example, we misplaced we forgot to close a scope or something, we're missing a bracket or something, I don't know, just syntax errors or whatever. We want to be able to see if the shader compilation failed because of one of these errors. So what we need to do is actually retrieve the log. So basically, we want to get the result of whether or not our shader succeeded. So if I just make an integer here called result, and then I get the shader. So if I just type in gl get shader IV, I can get from the Vertex Shader the compile status, or really anything I want. So this is like a property I want to get. And then of course we're going to find out what the status of that is by putting it into result. Okay, so now we can do something like if result equals false or gl false, we can handle it. Okay, so let's go ahead and get the log. So int length or gl int length, we'll get the we probably don't need most of this actually. Let's see though, info log length. Yeah, I don't think we need all of this. Let's dump it into a vector of chars. We need to include vector in a minute as well. So we'll dump it into here. We'll just create that so it doesn't have to resize it, and it knows how big it is. So gl shader info log. We're going to grab our vertex, our length again, because that's what it wants, and then the pointer to the first element. Okay, so one thing we'll need to do quickly is include vector. Okay, cool. So there you go. Yeah, okay, anyway, once we've got all that, we should probably print it. So we can go ahead and print it. I'll print it just to see out for now. Again, we'll have our logging system soon, eventually, which will print all of this stuff for us, so we won't really need to do this. This is just temporary. So error 0 end line. Okay, there you go. And then let's delete our shader because it's dead. And then I don't know, we can return something like, that's an unsigned int. So if we return something like -1, sorry, I just said it myself, it's an unsigned int. If we return 0, then it means that we failed. Okay? We could also throw an exception, but that wouldn't be the best of ideas. Okay. Next up on the menu. We do the exact same thing for the Fragment Shader. So fragments. What else? Wait, where's the? Yep. Okay, that's fine. Okay, good. So let's just replace all of this with fragment. We might print something like failed to compile. So failed to compile Fragment Shader. Maybe another end line, and then the actual message. So we can do something like that. There we go. Except in this case, it'll be vertex. All right, good. So we're looking better now. We're looking good. All we need to do now is not delete the Vertex Shader. All we need to do now is basically link all of them. So we've got two separate compiled shaders. Vertex and Fragment are now done, right? We don't need to really do anything with them anymore. What we do need to do is attach the shader to our program, okay? So we pass in program and then the shader, such as Vertex. So this is going to attach them to our program because remember, they're going to work together. Our flow is going to be, the Vertex Shader is going to then progress onto the Fragment Shader at runtime, right? So we need to link them so that it knows where it is. Then we do need to actually link them, validate them, and finally that's it. We can just return them. So return program. We don't need the actual shaders anymore, so we can delete them, by the way. So we can go gl delete shader, vertex, and fragment. So let's go ahead and do that. And we're done. Okay, there you go. Beautiful shader code. Hopefully all of this works. This is still giving us somewhat of an error. Expected a what? Oh, I forgot the colon. Okay, and there we go. So that's all good. Yep. So and then that gets set to load. So now let's go ahead and actually create our enable, not return. So GL use program shader, and by that I mean m shader ID. Make sure that's const. Copy and paste that for disable, and also set that to 0. All right, there you go, done. So that's the basic idea for a shader. So if we go back here, this is becoming such a mess. So let's probably clean all this out. We don't need any of the vex anymore. We will need that, but whatever. Yeah, whatever, bro. We'll keep this here, I guess. Okay, so we'll get rid of immediate mode. We'll keep our draw erase there. Okay, so let's test out whether or not this worked. So include graphics shader.h. Okay, we'll go ahead and create a new shader object. So shader. We'll take in the file paths. So right now I'll put them into, let's see, we'll leave them in source and we'll make shaders because, oops, no. So shaders, you'll have to copy them to the, you'll have to copy them out into the binary directory when you actually give the game to someone. Like if you run it outside of Visual Studio, if you run it inside Visual Studio, it's fine if it's in source. So we'll not make it a CPP file. So we'll make something called like basic.vert and basic.frag. Okay, so in both of these, I'm going to set the version to 330 core, and then all the fragment, this is the Vertex Shader. Okay, so the Vertex Shader will do a number of things. It will take in an attribute called. So we'll make sure that it's in the first location here. It'll be called position. Okay, that's all we'll take in for now. There'll be a uniform mat for PR matrix, which is the projection matrix, and we'll do stuff like view matrix and model matrix. Okay, these will be set to the identity matrix by default because I don't want to make them mandatory, whereas we do need a projection matrix. In fact, I'll even set that to just 1. No, we won't. We won't use that for now. So we've got our position, right? So what we want to set is GL. Have I just forgotten how to write shaders? GL, is it a GL vertex position? Is that it? Man, I've just had a complete brain freeze. No, it's not, is it? Oh, it's GL position. Lol. Sorry, my brain just froze. Okay, back to this. So, GL position will set equal to PR matrix times position. Now, if we are really nice, and we can ignore this for now, just to get the minimum out, and then we'll pass in a projection matrix. That's done. Fragment shader, a bit different. Where's my hash? Version 330 core, void main. Okay, so this will actually do the opposite. So layout location 0 just means it's in the. So this just means it's in the. It defines where the variable's location is, because anything that is in or out isn't actually, like, it's either imported from somewhere or exported from somewhere. So in this case, we set layout location to 0 so that we can actually pass in an attribute to the shader at this location. Whereas if we don't know the location, we have to retrieve it because we can't be guaranteed that it will be 0 every time, for example. In this case, it will be because we've set it to that. So it's much easier like that. You can also set layout location to uniforms, but I believe that's only in OpenGL 4 or above, and I want to maintain compatibility with probably about 330, so I'm not going to use that, but that is also very useful if you can set layouts for uniforms, but we're not going to do that. So out vec4 color. Okay, this can even be a float or a vec3. It doesn't really care too much, which is nice. But we'll output the color to be something like pink, for example. Okay, so RGBA. All right, cool. There we go. So those are two functional shaders which should do exactly what we tell them to. So let's go back here. Now, what was our immediate mode rendering stuff? Let me quickly find that. Sparky core source. I'm literally on GitHub right now, just trying to find out what I typed. Main.cpp. Okay, I just wanted the. So here they are. Let's copy them back in. So I'm keeping this here because I'm about to define that stuff. So we're in shaders, basic.vert, and then shaders, basic.frag. Great. So if I go ahead and let's just get rid of them for now. Run this. Build errors, GLint result redefinition. Really? Oh yes. So we'll just we'll get rid of the second one. More errors. Okay, unresolved stuff. Read file. Huh? Why are you unresolving me? And shader. Okay, yeah. So let's make sure we have the destructor. Okay, and by the way, in the destructor, we should probably put something like gl delete program m shader id. All right, probably a good thing to do. Okay, so read file is mad. Oh, it's defined multiple times. Okay, I see. So annoying. Yes. Where are we? Where are we? Where's my read file method? No. Utils, file utils. So why are we defined multiple times? That's annoying. We shouldn't be. Where else did I include it? Oh, it would have been main. Okay, let's get rid of this for now. We'll fix that later. Where am I using this thing? Read file. Already defined. Where? Let's just see. That shouldn't be included anywhere. That's weird. Have I missed something? Have I missed something important? Probably, but weird. Oh well. If we put this into a class, it'll go away. So we'll probably make a quick class for this because I can't be bothered fixing this right now. In fact, we'll make it a struct. Because why not, lol. No, we'll make it a class. I don't want to be creating structs with absolutely zero stuff that's not going to go down too well. All right. Okay. So this should work. Okay. Okay. So it couldn't find the file, it seems. Let's go into main. So why? Let's see. Shaders basic divert. Shaders basic divert. It's there. Let's quickly check this out. Where are you? Where are you? Let's go down here. Okay, what's vert path? Shaders basic divert. That seems fine, right? Shaders basic divert. And yet, you're annoying. Why are you so annoying? Okay. So okay. Let's see. Let's properly do this. So the problem with this is that it'll get deleted. Or okay, I'll explain in a minute. So vert source string. Okay, so the problem with this is what we were doing was we were reading the file which returns us a string, and then we're getting C string, and C++ is like, lol, this original std string is not being used anymore, so I'm going to delete it. And what happens with that is that C string is just a pointer to what is in here, and if that gets gone, then so does that, and we have massive problems everywhere. So we want to basically retain this. So if we do this, we shouldn't get such a problem because it won't be destroyed straight away. Okay, important stuff. Anyway, that should help fix that. I'm still not sure why it can't find our path, because it should. Oh no, whoops, that's my problem. I don't know why I can't find the path, because I'm an idiot. Make sure you have source at the front. Okay, so good. Well, actually not good. Oh really? Okay, this is not good. This isn't actually not true. Layout location does not require version 4.10. This is bad. Okay, something is up, and I forgot what it was. But it's not that. It's lying to me. It does that sometimes, by the way. Shaders will sometimes lie to you. Don't listen to them. It's probably something to do with my compilation. If shaders are lying to you, you know that you've messed something up. So, vertex. So the vertex shader 1. So what's wrong here? Fragment, frag source, fragment. Everything looks good. Gel fragment shader. Weird. What is wrong with this? Create program, ship vertex, and yes. There's probably a typo somewhere in here. This is why I hate this initial creation of shader code. Delete shader vertex, that's right. Fragment. Okay, let's see. This is a good way to quickly check. Yeah, seems legit. Is that legit? I think it's legit. So why is it crying? Let's quickly check this. Ugh, fine, just give me like freaking HTML. Oh. Wait. Does it have... It does have \n, good. So it does have that. Frag is correct, I hope. Oh, hang on a minute. Out vec4 color is what I meant to say. I love how I caught that in the... Rather than actually reading the shader, I caught it in the freaking... Like in like here. In this tiny space, I was like, lol, that's wrong. Okay, cool, so this should work now. Weird how it starts lying to you, though. It's like, whoa, you want to use layout? Bro, that's like version 4.10. So I don't know why that's a bit weird. But anyway, we've got no errors now. Good. Now, it's good that we had a few errors because we managed to test the error checking system that way, which is always good. So now that we've got that, we should be able to enable our shader and then do cool stuff like, let's test this out. So let's be like, I want a, this is going to be a long episode. Hope you guys are ready for that. GL float vertices equals, and I want to set it equal to this, and yeah, we'll just automatically initialize it. So, this is where I wanted to have my my original vertices, so I wouldn't have to really think too much. So we're basically going to just do this. So yoink, or in fact, if these were aligned, which they now are, I can just be like, lol, thank you. Let's take a few of these. All right, cool. So we got 4 vertices now. We need indices or 6 vertices to make a rectangle. So let's see. I should just copy that one really. So that, and then we need one more, which I think is that, and then we need the first one. All right. So, lol, this is just, what is up? I want this here. Okay, I'm just going to quickly align everything. That looks pretty good. I'm not even going to double check that. I don't really care. We'll see. Result. So, we need to create this stuff. So we've got that. Bind vertex arrays. We don't even need a vertex array. Goodbye. VBO GL bind or GL gen buffers. I want 1 buffer, please. I want to bind you in a non-aggressive way. Array buffer. And VBO. And then I want to buffer daughter. So GL array buffer. So I'm giving it the data now. So I've generated an OpenGL buffer, which is just like an array, right? Full of data. And then this is the data I'm giving it. So it's going to be size of vertices. So this size of, it wants it in bytes. So we can just say size of vertices. The data is going to be vertices. And then the usage is going to be just GL static draw. Cool. Now, this data is now in OpenGL, which is fantastic. But we need to also transmit this data to the shaders so that it knows what to do with it. So we can do that by using a vertex attribute pointer. Now, if you use one of these, vertex attribute pointer, if you use one of these outside of a vertex array, it's kind of global. So just keep that in mind. So when we actually make this and we actually have a proper renderer, it will use a vertex array. But this is just an example, of course. So let's see, what does this want again? Please help me. So index 0, size 3. So it's 3 because there's 3 components to each vertex. Type GL float, normalized GL false, stride. We can just leave both of these at 0, and then GL enable vertex attrib array. A lot of stuff to type there at index 0. Okay, and then if we do that and we draw to the arrays with 6, hopefully this will not work, of course, because of course I've forgotten something. Question is what? Oh, I didn't enable my shader. So, yes I did. Okay, what did I do? VBO, let's bring this down. It's downstairs, so it's a bit closer linked. They seem legit. I am drawing my beautiful arrays. The buffer is bound. Vertices are correct. Buffer, gen buffers. Everything should be working. Unless I've missed something. Have I missed something? I probably have. Stream, help me out. GL float 3. Yep. Seems pretty legit. I don't know. This seems fine. Let's try putting it into a VAO. It doesn't really need one though, so I'll be surprised if this works. What does this want? Yep. Interesting. What are my shaders saying? They want a vector position at location 0, and that's it. Okay. Well. Oh, hang on a minute. Why do I have GL array buffer here? That'll be why. Yay. Oh my goodness. That's silly. That code was in there anyway. My goodness. Okay, so we don't need this anyway. Okay, let's get rid of that. Okay, there we go. So we should be getting a pink thing on the screen. So it's a bit weird. Done. So anyway, now that we've got that, let's try and meddle around with the projection matrix and see what will happen. So the first thing I want to do is, if we are doing something like a projection matrix, and I make a map for called ortho, and I set that equal to mat for ortho or orthographic, and I do something like 0, 16, 0, 9, near and far, we'll just set to like 1.0, 1.0, if I do something like that, and I want to pass it into the shader, I have to do something like GL shader, GL uniform for FV. Oh no, sorry, there's a special matrix for it. Matrix for FV. Location being, well, I need the shader's location, so that's a bit annoying. Let's quickly just make this public for now. Remind me to turn that off later. So shader dot I need the ID, I need the count, which is 1, because I want 1 matrix for. Transpose, no, and then the value, which is just going to be mat4.elements. Not mat4.elements, ortho.elements. And we should probably get rid of get column as well. Anyway, I have to do this whole thing, right? And then I have to be like, wait, hang on. No, I'm wrong. I don't actually need that there. I need the location of the, because I was like, where do I put the location of the shader? And then I'm like, lol, I don't need that at all. So GL get uniform location, PR matrix. You want the shader as well, don't you? Yep. Okay, cool. So now we've got this big thing here, which sets our matrix appropriately. So if we go back to our basic.vert and uncomment the PR matrix, we should see this, right? So clearly our projection matrix worked, and that actually does look like it worked. So if we go into main and we make this, let's just say 15. No, we can't make it minus 15. So let's redefine these vertices as being something like, so I'll make the first one at 0, 0, 0. Then I'll make one at like 15, 0, 0. And then I'll make one at 0, 15, 0. That's our triangle. In fact, well, let's just draw a triangle. Whoa. So let's maybe make this at 8 or something. So I'm making it just below the thing so we can see if it's working. And yeah, it looks like it's working, right? So there's our wonderful... I am, unfortunately, going back against the spirit of the rectangle. I probably shouldn't be doing that. So let's fix this up quickly. What are we, 16, right? So let's put this to 12. Okay, so this should be half a rectangle, right? Absolutely not. Not 0. What are we, 9, right? So let's maybe go 3 and then 6. What am I doing? 4, 12, 0. No. 4, 12, 4, 3, 6, 3. No, wait. Okay, let's leave this on 3. And then put this one up to 6. I don't know what I'm doing. There's half of our rectangle. Let's do the same thing. So we'll need that, and we'll need this here. Okay, there we go. No. Well, yes, I just need to actually draw it. The guessing game's not working out for me. It should be. Two. I need a second one. Yay. Okay, anyway, that's the idea. We've got a rectangle now. Yeah, so the problem is doing stuff like this is a bit annoying, okay? We want to abstract that and make the shader do that for us. So let's do that. So in shader, which is over here. By the way, people who are watching this on YouTube, could you please post a comment about your feelings regarding these long episodes? Because I know that if this is being live streamed, and for people on the stream, long streams are good. Like, everyone seems to like long streams. But if each episode of Sparky is like an hour or more, I feel that maybe people won't like that as much as like maybe 20-minute videos. So we'll see, because I could try and split that up if you guys want, but it's up to you. I mean, I'm happy to do this. It's actually easier for me if I don't split it up. But anyway, we'll see. Am I still recording this? Yes. Good. Okay. So we'll go ahead, and it's getting late as well. It's freaking 6. Okay, we need to accelerate this. Okay. So anyway, I'll make this private, and then what I typically like to do is what I typically like to do is actually pretty much make a method for setting all kinds of uniforms in here. So I could have something like void set uniform mat4, for example, right? And that is our example with matrix. And then all this has to take in is the actual mat4 that we want to do. So we do need to take in a name, right? Which is just going to be like a string of basically what we want to set it to, right? As in what the name of the uniform variable is. And then we just need to take in this case, a mat4. So const mat4. What am I doing? Const mat4 matrix, right? Yeah, we do something as simple as that, and we'll include maths as well. Okay. And then if we want to go ahead and there's so many of these, like if we want to set uniform 1F or 1I, this is basically what I typically do, right? And then over here we take in the float. We don't really need to take floats in by const reference. So float value, int value, you know, all these crazy things. 2F, 3F, so for our vectors, and we can get these to actually take in stuff like maths vec2. Obviously these will be const. Maths vec2, vector, and then maths vec3 vector, and then vec4 vector. Yeah, and we can do all that fun stuff. And I think that's probably about it for now. So all of this cool stuff that we can do, that's what I typically do, right? Because then we can just simply call the appropriate method and we're all good. So let's quickly implement all of these. They're very short methods. They'll be like one line each. Oh, and we also need a big one, which is GL, what is it? Int. I think it's just int. Yeah, because -1 can be a value. So it's a signed int of shader. Oh, sorry, we're in shader. And this is just called get uniform. Okay, so this gets the uniform location. In fact, I can just call this get uniform location. All right. Actually, that's the same as the OpenGL one, isn't it? Is it? Where's main? Yes. No, it's GL get you. Okay, so we'll just have get uniform location. Okay. And this will be just a name. Okay, and then this is just good for getting the actual location of a uniform, which we need for these ones. Okay, and we'll make it public. We'll make it private because I don't think people should be using it. Otherwise, you're doing something wrong because the shader should be doing everything. And if not, you can just use OpenGL's method if you really want to. Okay, cool. So, shader, so here are all of our lovelies. All of our nice uniform stuff. Okay, so GL set GL uniform 1F. So location is going to be get uniform location name, and then the value is going to be value. All right, pretty good. Where is our set location? Did I implement that at all? I don't think I did. Where is it? Oh, it's get uniform location. That's what I used. Why are you mad? Why are you mad? Let's implement that. I think I did implement that. Okay, so this will be simple. Now, this is a slow operation, getting the uniform location. It's very slow. So we will cache these eventually. I'm not going to do it this episode. I'll do it in the upcoming optimization episode and maintenance episode, which I believe will be about episode 10-ish. So I'm not going to bother with that now because, well, time is going on. This is a long video as it is. But yes, this is a very slow operation, so you will want to cache these locations. Anyway, GL get uniform location name. So right now we'll just do this. M shader ID. Okay, there we go. Done. So anyway, this you can copy and paste wherever you like, and literally all you'll need to change is like this stuff. Lol. I don't know why that's an error, but whatever. What is this? 2F. Why is this an error? It's confused. It's very confused, but that's all right. We'll let it be confused. Vector.x, vector.y. Vector.z. Now even vector's confused. It's just, the whole thing is just very confused. That's all right. Remember, children, IntelliSense errors aren't real errors. Okay, and finally, we have this. Now, this is a bit different. In fact, let's see. Let's just copy this, because that's what we did. So, back in Shader. So, matrix.elements, and that's it. My goodness, it's just forgotten about. This one's like, oh, I know where you are, and this one's like, nah. Oh, well, actually, I'm an idiot, but I guess we can just blame everything on IntelliSense anyway. I mean, IntelliSense isn't bad or anything. It's just sometimes it's a bit confusing, and sometimes it's misleading, but usually it's good. It's better than anything else that exists anyway. This is because I didn't change this. All right. Everything else looks pretty good. So, the hood is good. Let's go ahead and go to main. Let's quickly go ahead and say, make sure you have its shader enabled, by the way. If you don't and you try and pass a uniform, it will yell at you. So if we set uniform mat 4, now all we should be able to do is be like, I want the PR matrix to be set to my ortho. That's it, right? And if we run this, it should work. It did work. Cool. So, there we go. That's pretty much it. That's going to wrap up this episode. One other thing, I guess we'll test out another cool thing. In fact, let's do this. Let's go back into basic.vert. Let's grab these ones. Let's multiply them here. Okay, so obviously these are 1 by default. So if we run this now, it should be the exact same result. Fantastic. But back in main, if I were to go ahead and shader.set uniform 4 to something like mat 4, sorry, to something like I don't know, the model matrix, so we can change, well, model or view in this case wouldn't matter, but I want to translate something. Did we call translation and not translate? Really? What about rotate? It's rotation. I don't know why I named them like this, but whatever. Vec3, something like that, whatever. Oh, actually, that'll stop rendering it. Is that what you want? Is that what you want? Why are you so sad? Okay, that seemed to work. I'm not gonna complain. I think that's working. Let's try rotation. Around the z-axis. By 45 degrees. Yay. Okay, so it seems to be working, right? Which is good. So, there you go. The weird offset is because of a number of things, but it works, which is good. It's basically because it's not in the center. So really what we should have done is, I'm not going to do it now, but in fact, I will do it now. Let's pop this back to 0, 0. So we'll subtract everything by 4, it looks like, and 3 for the other thing. So now it is being rendered there, and the rotation should be working. The rotation should be against the corner, which is right here. All right, and it looks like that's fine. So if I go 90 degrees, won't really work, but you guys get the point, okay? And if I want to get into that particular place, I'll probably just leave the translation in there. We wanted to, how much was it? It was 4 and 3. Okay, there we go. Yay, cool, fantastic. So let's try setting some more shader things. So shader.set uniform for 4F, for example. We can set the color, so we can be like cull, or I'll just call it cull. Or I'll be extra confusing and call it the Australian spelling of color to a vec4, so maybe like 0.2, 0.3, like same as our clear color basically. I guess that'll be a good way to test it. I'll probably change our clear color to white in a minute. Then we'll go to our fragment shader, be like uniform vec4 color. I love that naming. The best naming ever. So now it should be invisible. Either that or it's not working, but invisible also floats my boat. So let's set this to 1 to make this background white. I kind of like white more than black, I think. Okay, fantastic. It's almost like we flipped the colors, but yeah, although it used to be pink. So we can set colors now, which is good. And let's do something like shader.set uniform 2V. That's a lot. That 2F. That's the last thing we'll check, and it'll be something like light position or something. We'll set that to like, what's the center of our screen? Well, I guess we'll just set it to like 8, 4.5. We'll be as close to the center as we can be. Well, that is the center, but anyway, we'll set that. We'll go into one of our shaders. We'll be like uniform vector light position, and then we can be like distance is, or intensity equals like 1 divided by length of, we need the length of the position as well, so this is probably becoming quite big, but out vec4 pos equals position length of pos minus light position times intensity. Okay. Lol. What's wrong with this? Let's quickly diagnose it. Is it just too bright? That's an option. Let's set the clear color to 0. Hang on a minute. Yeah. Let's just set the clear color to 0. What is something that's not white? Oh, okay, that's bad. That means there's an error. Light position vector. This is good. It might be this. But we've got an error though, so that's always fun. Where is our inform vector light position? That's correct, right? It's a vector. Oh, this is not a vector. Yeah, there we go. Okay, all good in the hood. Wait, was that a shader error? It would have been, right? Let me close all this stuff. It would have been, right? Maybe I just didn't notice the console. Yeah, it would have been a shader error. Hang on. Yeah, it is. Maybe I needed to like pop up a message box being like, ugh, to scare me or something, but I don't know. Let's try this. Cool, lighting. So there you go. Let's get rid of that hideous color. Okay, so there we go. So we got a bit of lighting now. I might just make it black, to be honest. Or we can just... We'll leave it as white, but then we'll just get rid of that. Yay. Okay, cool. So there we go. We've got a basic light. That's not the center. Ah, what's wrong with this? Why is it not in the center? What's our... Oh, wait. No. That should be correct. I'm confused. Why are you not in the center? Weird. It's very weird. Oh, of course. Yeah, so things to the center is that. So we need to set it to like well, if we want it to be in the center, we can just set it to 1.5, so pretty cool. Almost looks like there's a bit of a lens flare as well. Cool effect, huh? So there we go. That should demonstrate that shaders are working pretty well. Cool. Any questions? Leave them in the comments below. This will be on GitHub, of course. And the next episode should probably be tomorrow-ish. We'll see. Anyway, hope you guys enjoyed this episode. Please don't forget to hit the like button if you did enjoy it, and I'll see you guys next time. Goodbye.